Welcome back to C# tutorial for beginners. This time we're going to continue with our inheritance and talk about polymorphism. So in the last video we talked about how inheritance worked, what base class and derived class were, and the syntax of how to inherit. We had a doctor that was an employee was a person. So we know what it does and how it does it, but why? Why wouldn't we just add an employee ID and a job title string to person and not have all of these different classes? If it's not clear what you're getting out of using inheritance and you can't even see it becoming useful in the future, there's a good chance you might not need it. But that's why inheritance starts at design. So let's talk about a real life example. Let's say we got hired by a hospital to create a database application that manages all of the people that deal with the hospital. Now, two of the very big features of this application would be the ability to log in and the ability to manage all of the people. So if we take a look at login, we know we're going to need a user. That user could be a normal user or it could be an administrative user. And I think that's a good place to start for our models that would have to do with login. So if we start breaking down the ability to manage people, we know the hospital is going to have employees, we know they're going to have patients, and we know that they're going to have visitors. And that might be fine for a simple database, but our hospital wants to do scheduling and billing, so we need to break our employees down. So we're going to have doctors, we might have nurses, we might have custodial staff, and then who knows who else might be an employee of the hospital. We would also need to keep track of what type of patient we have. Is it an ICU patient? Is it a maternity ward patient? And for the visitors, maybe we need to know what patient that the visitor is seeing. So now let's be crazy and say that this is everything that we need to make this database application. So all that's left to do is to figure out how we're going to structure our code and our database. So let's start with people because it's more complicated, and let's see what we have. So on this level, we have employees, patients, and visitors. So one of the first things we're going to need to ask is, what do these things have in common? Is there a common piece of all three of these that we don't want to duplicate between them all? I think the answer is yes, because all of these will have to register a name, an address, a phone number, social security, any of that kind of data that we're not going to want to duplicate in our code or our database. So we're going to create a parent class person and use this parent class to store all of that information. So we will have employee is a person, patient is a person, visitor is a person. Now what we have done is we have split person three ways instead of the single path we took last video. So what we've started here is called polymorphism, and that's using something to cover multiple forms. And we'll see what exactly that means for us when we implement this in just a few minutes. So now let's look at employee. So we know our employee can hold information like the employee ID, maybe where they work, their office number, all of these very common things to all of these employees. But now we have to ask ourselves, are these different enough to warrant their own class? So maybe employee just needs a job title, and job title could equal doctor, nurse, custodian, or whatever. And that might be good enough. While in real life, these would probably have a lot of unique properties. Let's just say they have one. Let's say doctors have a specialty. Let's say nurses have a qualification. And let's say custodial staff has a specific schedule. Even with these few unique traits, it can be worth creating a unique class for these, making a doctor an employee, a nurse an employee, and a custodian an employee. And there's multiple reasons for this. The first one is code management. So if you have a specialty for a doctor, qualification for a nurse, and a schedule for a custodian, and you put all these into the employee class, everybody would be an employee, but if the employee is a doctor, he wouldn't have a qualification or a custodian schedule. And if he was a custodian, he wouldn't have a doctor's specialty. So not only does that not make sense, you're wasting resources. Another reason is now that we've gotten unique, maybe we want to find every nurse that has a certain qualification. Well, then to do that, we would have to find all of the employees first, then go and figure out which one of those employees are nurses, and then sort it by qualification, instead of going and getting all of the nurses and then going straight for the qualification. So now we've sorted these out. What about the other employees? Well, that's kind of a judgment call. If you think that other professions may have more specifics in the future, it may be worth creating those classes, inheriting from employee and leaving it there. Or if you want to just be more generic with everyone else for now, you could just create them as employees. So now let's go down to patient. We have to ask ourselves again, is an ICU patient and a maternity patient that different? Or is this really just location? If it's different, you may want to have an ICU patient that is a patient that is a person, and a maternity patient that is a patient. That may be something you want to do, but for this purposes, we're going to say that this really just represents where they are. So this would be boiled down to a field called location, and then that location might be set to ICU. And then the same thing with visitor, the patient that's visiting them, we're just going to call that patient, and that's going to be a field as well. No need for a new class. So now we've decided we have person, employee, patient, and visitor are person. We have doctor, nurse, and custodian, and those are employee, which is also person. So let's take a quick look at ability to log in. Now, similar to the location and patient, I think we'd be able to boil normal and admin users down to a Boolean that would be is admin. The real reason I created this section is to point out a potential pitfall, because you may see user and automatically say, I can inherit from person because a user is a person. Well, that might be true, but you need to take a close look because these are two separated portions of your logic. Person was designed to be a generic person that represents people that the hospital deal with. So person might actually have qualities that a person that is a user might not have and have no business being in user in the code or the database. So you just have to take a close look when you try to use inheritance across different pieces of your logic. Okay, so what I've done is I've implemented this portion here in classes. So I have a person, a visitor is a person, a patient is a person, employee is a person, doctor is an employee, custodian is an employee, nurse is an employee, and then I've created a very basic object of each one of them. So a new person, visitor, patient, doctor, nurse, custodian, and a regular employee. So we've already seen the usefulness of inheritance when it comes to accessing properties of a parent class. But now let's talk about implementing polymorphism. So we already talked a little bit about polymorphism, being able to make one thing take multiple forms, like visitor, patient, and employee are all person, and doctor, custodian, and nurse are all employee. But how do we make use of that in our code? So let's pull this back to full screen, and let's create a new list of person called people. And from what we've learned so far, we know that we can accept a type person, which we have one here called person. Let's go ahead and add person to our list here. But what we also know is that visitor, patient, and employee inherit from person. So technically they are of the person type as well. So we could add visitor, patient, and our software engineer, which is type employee, to our list. So now we have 4 different types inside of our list of person, because when it comes down to inheritance, they are all of type person. Adding on to that, we know that our doctor, nurse, and custodian are type employee, and all employees are persons. We can also add doctor, custodian, and nurse to the list. So every single one of these inherits from person. No matter what level the inheritance is on, they all trace back to person, so you can add them to a list of type person. Now, just like we did this, you could create a list of employee if you wanted to say load all of the employees. And now once you do that, it says, hey, person, visitor, and patient are not employees, but guess what? All of these other ones are. And of course, from there, you could get specific if you wanted to. Say you only wanted a list of your doctor, then only doctor could be added to that list because it is the only one that is actually of type doctor. So now you can start to see how we can store multiple forms into a single type. And that's the base of polymorphism. But let's show how we could use that, say, in a method. So we could actually write a method void print name, and we could take a person and we could do a console write line person.get full name. So now we have a method that takes our generic person, which means we can use any of these types with it. We could actually say for each person, my person in people, print name, my person, and it will call the get full name method deep down in the person class of all of these derived types. So generically, we created one method and we didn't have to create print name that took a visitor and print name that took a patient, etc. We were able to do it in one place that takes many, many forms through inheritance. So I know we're already a little bit outside of beginner territory, but I just want to throw this in because if you've already got a method like this, you take a generic person, which can have many forms passed to it. Sometimes you need to know when you get in this method what type your variable actually is. So maybe we need to do something special if this person is actually a doctor. So we could say if person, then the word is, and then the type. So we're saying if the person is type doctor, then we do something. And there we're just writing the doctor's name. So the next step is diving into abstraction. So I know this one was a little long and probably a lot painful. So thank you for watching, everybody. I hope it was helpful. Happy coding, and as always, until next time, take care.